So in this practice question, in this assignment, you are asked to write the I.U.P.A.C name. So you have written correctly the name of this compound, and it is 1, 2, 3 because double bond is there and there is no other functional group that is given priority over the double bond. So the name is 3-bromo 3-bromo prop 1-ene. Correct. And now there is a functional group, carboxylic group and hydroxy group, and numbering start from carboxylic group because it is given priority. So if it is given priority, so we use the suffix for carboxylic acid, that is oic acid, and for OH we use the prefix, that is hydroxy. So its name is 2-hydroxy propanoic acid. Propanoic acid, and we do not need to number the position of the oic acid because it is always on the terminal, and if it is given priority, so it is always number 1 carbon. And now for the number 3, this is the basic chain or the parent chain, and priority is given on the ketone because this is ketone and this is hydroxy. So we start the numbering from where ketone is nearer. So this should be the numbering. So this is 4-hydroxy. Again, the same reason, because hydroxy ketone is given priority. So we use the suffix of the ketone that is on, and we use the prefix of the hydroxy. So this name is 4-hydroxy, 4 carbon, but, and all the carbon bond are single, butane, omit the E for avoiding two vowel sounds. So it is butane to on. And even you can ignore the leucine position here because up to butanone, the ketone group is always on the second position. But I suggest you better to write the position as well. And now the next one is here, amine group is there and hydroxy group is there, and both are on the same position. So regardless of their position, we give priority on alcohol. So we start the numbering from here, 1, 2, 3, 4, 5. So the name of the compound, we first write the prefix of this NH2, that is amino. So the name is 4-amino, and carbon chain is pentane. So it is pentane. Omit the E and write the suffix of the compound. So this is 2-ol. So the name of the compound is 4-amino pentane 2-ol. Next, now this is the functional group double bond, and this is subordinate group just like the methyl group, but it is not methyl, it is methoxy. So we start the numbering from here, 1, 2, 3, 4, 5. So the name of the compound is 4-methoxy, and total 5 carbon atoms are there. So the parent chain is pentane, not pentane. It is not pentane because you can see there is a double bond and double bond is on the second position. So this is pan to ene. So the name is the 4-methoxy. This is methoxy, pan to ene. And here the basic chain or the parent chain is this one. So if parent chain is this one, then we should observe what are the groups. So remember that parent chain contain 4 carbon atoms. Okay. And the two functional groups here are this is ester group. This is ester. And this is the carbonyl, and specifically this is aldehyde. So when ester and carbonyl are both present in the chain, then the priority is given on ester. Uh, the priority order is given on the table that I have shown in previous lecture. And when naming the ester, the alkyl group attached to the single bonded carbon is written first and without any number, because it has no number, it is not on the basic chain. So this is the methyl group, and there should be a gap between the name. And this is given as prefix, and prefix for ketone and aldehyde both are same. This is oxo. So where is the oxo? 1, 2, 3, 4. 4 oxo. Here the number, the position must be mentioned, because oxo could be for ketone, oxo could be for aldehyde. So we don't know whether it is aldehyde or ketone. So the number is important. 4 oxo, and total carbon atoms in the chain are 4, 1, 2, 3, 4. So this is bute, and all the carbon-carbon bonds are single. So it is butane, and we avoid E because of the suffix oate. Oate is the suffix for ester group. So this is butanoate, and we do not need to mention the position here for oate. Okay, so the correct name is methyl 4-oxo-butanoate. And now, no one is the functional group, but these are the subordinate groups which have no suffix. इनकी कोई suffix नहीं होती. If they have no suffix, so number is same whether you start from 1, 2, 3, 4, or you start from here 1, 2, 3, 4. In both the condition, groups are on second and third position. But here we should follow this alphabetic order if both of them are halogen. It is not for other cases. It is specifically for halogen. If two halogen are on the same basic chain, then we should give it should be given priority in alphabetic order. So in alphabetic order, bromo comes first. So numbering start from here 1, 2, 3, 4. So the name is 2-bromo 3-chloro butane. Got it? Wait for a minute. I will restart from here. Okay, so we were here. And now this is the compound where one functional group is here, that is aldehyde. One functional group is there, that is amino. So now these functional group must be the part of the basic chain. And here we will follow the longest chain 1, 2, 3, 4, 5, 6. This is the longest one. If you go straight, then this is 1, 2, 3, 4, 5. So the longest chain is this that contain all the possible functional groups, and numbering if these two groups are there. So priority is given to the aldehyde. So this is 1, 2, 3, 4, 5, and 6. So the parent chain is containing 6 carbon atoms. And the position of the groups are amino on the third position and 2 methyl group are on the fourth position. And again, use the alphabetic order for writing the prefixes of these groups. Methyl start from M and amino start from A. So first we write 3 amino, 4 dimethyl, and then we write the name of the basic chain, that is hex, and all the carbon-carbon bond in the chain are single. So N, and we omit the last E of the N, and we use the suffix of the aldehyde, that is al. So the name of this compound is 3 amino 4 dimethyl hexanal. And for writing such suffix, because al and all are very similar, we should write the letter very clearly. Okay, so this is al very clearly. And now this is the compound, and you have written its name correctly. 1, 2, 3, 4, 5. If you start numbering from here, then 1, 2, 3, 4, 5, 6. So the second and the fourth position is ketone, and there's no other group. So we can write its name hexane, because there is no double bond in between carbon atoms. And we do not omit E because the next letter is not vowel, because second and fourth position both are ketone. So this is 2, 4 dione. So because there is no vowel sound, so we retain this E. Okay. So the name of the compound is hexane 2,4 dione. Got it? Now, if we compare 8 and the 10, then you can understand that the functional group must be the part of the parent chain. So we ignore the longest chain and we follow this. This is the longest, this is considered as the parent chain. So as in initial lectures of nomenclature, I told you that this is not necessary always that parent chain is always longer, because it has certain properties that it should have all the possible groups and the functional groups. And then we see whether, if including the functional group, there is the longest chain, then we will prefer as we have preferred in compound number 8. But for compound number 10, we do not prefer the longest chain, but we prefer that all the functional groups should be there. So this is the parent chain. Straight chain is the parent chain. So now this is aldehyde and this is carboxyl group. So we know that carboxyl group is on the top in priority order. So this is 1, 2, 3, 4, 5. Groups are, this is ethyl, this is methyl, and this is amino, and this is oxo. And positioning of the oxo is important. So amino comes first because it starts with A. So this is 3-amino, 2-ethyl, and now methyl or oxo, which come first? M and O. So M comes first. So we write 2-methyl, 5-oxo, and the total number of carbon are 5. So pentane, and the last one is the carboxyl group, and it do not need to mention the position, oic acid. So the name of this compound is 3-amino, 2-ethyl, 2-methyl, 5-oxo pentanoic acid. So that was the practice for nomenclature, and we will do such practice in our other lectures too on inshallah.